get ready for the next presentation. And the next presentation is about something like this: blockchain and self-sovereign identity. So that's our presentation title. And we have a gentleman who is a blockchain technology enthusiast, entrepreneur, and also an engineer. Over 15 years of experience in software development, design, and delivery on a wide range of technologies and business domains. Proven experience in building and also managing technical teams. Could you please put your hands together to the blockchain enthusiast and founder of Radical, Ledger, and Fidenz, Mr.Chim. Himidumage.
Hi everyone, hope you all could hear me clearly. As introduced, I'm Chim Himidumage. I'm the founder of Radical Ledger, a company completely focused on blockchain-related developments. And I have previously founded a company called Fidenz Technologies, a development services company, and I'm an engineer by training and have been developer for more than 20 years, I should say. So today I would like to give a brief introduction to blockchain and a couple of technologies around that. I hope you'll be able to gain some understanding of what blockchain is, how blockchain works, and possible use cases of blockchain as well. To begin with, just let me get this sync first. Yep, all right. Yeah, so I think you have some understanding of what I'll be presenting. So I would like to move on to explaining what blockchain is. Before explaining how blockchain really works, I would like to give a brief explanation of how blockchain came up. I mean, how blockchain came into the existence. What really happened was back in 2007, there was an economic meltdown in the world, like a bit of a recession in the world where the banks collapsed, the stock markets crashed, and a lot of employees were laid off from a lot of companies. It was a world recession, I mean, the most recent world recession which has happened. So this was like, some people started investigating what really happened. So there was a group of people or an individual claim as they call themselves as Satoshi Nakamoto. They realized the problem with this, the reason for the meltdown has been the entities that they trusted to be trustworthy has not been acting in the same way. Meaning they haven't really reveal the truth about their real financials. They haven't been truthful to their accounts, their audited records. Everything has been cooked, or those were not the real information. So with this, they realize trusting set of people or an entity or an institute is quite dangerous, because people behind that, even though the systems are so strong, the people behind those could be not trustworthy people. So this group of people or the individual decided this need to be changed, and he came up with a system which can be trusted as much as you want, can be fully trusted, but still there's no one really behind it and would not be governing it. So this is what blockchain is, and this is how the blockchain came into an existence. So basically, he came up with a white paper back in 2008 or so, and he created the first blockchain. They call it the Genesis block, was created in late 2009, and that was the start of blockchain. So that being the history, let's move on to, all right, how blockchain works. How I'm going to explain this, I'm going to define few terms or key attributes of blockchain. I'll be defining a series of attributes of blockchain, which would eventually explain how blockchain works. So just try to keep a track of each and every explanation. Then I think it will be really easy for you to understand how blockchain is. Just to begin with, I would like to, the concept hashing. Hashing is basically an algorithm. If any of you are a programmer, definitely you would know what hashing is. Hashing is a simple algorithm. What it does is it takes a text or some sort of any text input, and it run the algorithm would once it will it will go through the algorithm. Once you run the algorithm against the text, it produces an output which is fixed in size. That is the first quality, and then it further. There are further other qualities which once you make this hash, it cannot be reversed. Meaning basically looking at the hash, you cannot ever guess what has been the source for this or the input for this. The second quality is basically, if you change the input even by a letter, like here I have changed it, the simple letter E to uppercase one. Even though you make a even slightest change to that text, the output going to be completely different. And looking at those outputs or comparing those outputs, you could never guess what change has happened or what has been changed. Okay, this is funny explanation about hashes. I'll quickly go through it. Given a chicken, you can make sausage. But starting with a sausage, you cannot ever make a chicken. So hashes are like that. It's one directional. Once you make it, from the output, you can never guess or make the input that you provided. All right, the next concept or the attribute that I want to describe is a transaction. It's quite simple. If you go into simple financial terms, it basically, say, one person, Amarasiri, giving 100 rupees to Premasiri. I just wanted to get rid of Alice and Bob, which is famous. If anyone has studied private key, public key, private key infrastructure, you would know what I'm talking about. So a transaction is a simple transaction. Person A has given amount of money to person B. So that being a transaction, a block in a context of the blockchain is set of transactions that has happened over a period of time. Extremely simple. It's obvious. So let's go ahead and put these two concepts together. The block hash, which basically the transactions in a block would be, you will take all the transactions and the content of all those transactions, and you will create a hash out of it. But before creating a hash, you will add few things into this before creating the hash. So let me explain. Let's see what's next. Just move on to mining. You would have heard what mining is. It's quite famous with Bitcoin. Bitcoin mining is quite a familiar concept. But to explain what mining is, let's get into the concept of mining. Before explain what mining is, let's figure out what the few things that I mentioned earlier. Basically, to create the hash for the block, you need the hash of a previous block. So eventually you will understand what exactly happens there. Not only that, addition to the hash of the previous block, you need to add something called nonce. Nonce is a random piece of data. Nonce is a random piece of data that you will be add into the block before creating the block hash. So I'm just illustrating it further. You have the hash of the previous block. You have the set of transaction, and finally you have the nonce, the random piece of data. Then we put all these together and create a hash. Send it through a hashing algorithm, hashing function, and create the hash for it. So creating the hash for a block, you will have these three components, and you will be sending that through the hashing function. Then you will get an output for that. Quite easy, but when you do that, there's one more condition that need to meet, which means the hash that you are creating. Hash is basically a numerical number. numerical value, and this numerical value you are creating has to be lower than a specified value by the network. I mean, it's a predetermined value, which is called the difficulty. It has to meet the criteria of being lower than the difficulty. So to achieve this, as I said, if you given an input, you will get an output. But if the input is constant, the output will be again constant. So just to make sure that you can create the hashing number lower than a particular given value, what you have to do is you have to change the nonce. Nonce is a random data, as I said. It will always trying out different nonce, and we'll try to create a hash which is lower than the specified number by the network. So that is the difficult part. It is a completely trial and error mechanism. You have to try different nonce and see whether you can create a hash which complies the requirement of the network. So this process of creating this hash is what's called mining. So this consumes processing and energy. So this is the part that people get rewarded with people get rewarded with money or Bitcoin or whatever the coin cryptocurrency. So now we know what a block is. You know block hash. So if we try to understand what blockchain is, blockchain is we can take this as a possible structure for a block. This will not explain. I mean, this does not have all the elements of a block, but we could think of this as a possible block. So we have one single block, and then we will be creating the second block. When we are creating the second block, what we would do is we create the hash of the previous block, and then we will be adding that to the following block, and we'll be creating a second block, and again we will continue the process. Every time we will be using the block hash of the previous block and creating the next block. So since you are using the most recent block, the hash of the most recent block, the series of blocks is going to be chronologically ordered. So everything will be in a particular line in a neat and tidy manner, laid in the chronological order. So it creates chain of blocks, and so the name blockchain. So once you create a blockchain, again, this blockchain, you can think of this as a huge database. Like you have series of blocks stored in a file or a database, some sort of a storage in your computer. So the place that you store these blocks could call as a node in the network, and as you know, there are so many nodes in a blockchain network, and what happens is the block that you created will be transferred to all available nodes in the network. So it gets distributed across the network. Yeah. So we have the transactions. We have this transaction in a block, and let's see what it would take to change a transaction. Say you have a particular transaction in the block A, and you try to change it. Say the initial transaction, Premasiri gave Amarasiri gave 100 rupees to Premasiri. You want to change this from 100 to 105. So you have to go ahead and change the transaction. So you change the transaction, and you have the previous hash of the previous block, and you have nonce. You try to create the hash. The hash that you create gonna be definitely different from the previous one. So since the hash going to be used in the following block, you have to create either you have to create the same hash that has been created previously, which is not possible. The only possible way is create a new hash and go ahead and mine the next block as well. But when you try to do that, you have to put the entire effort of trying out different nonce and making sure you find the right type of nonce for the following block. You find the right type of nonce for the hash to be comply with the requirements set by the network. So eventually, what happens is if you change a transaction in a block, you have to basically mine all the blocks followed by that particular block. So it's a cumbersome task, and with the time, always the new blocks get added. So it's a fight against the time, and mathematically it has been proven that cannot be achieved with the available or the computing power that would be available in near future. With quantum computers, it would be possible, but that is not exist at the moment, and for the current conditions, it's mathematically proven that this cannot be done. So, which leads, which gives us some sort of a guarantee about what the reliability of blockchain is. If you really want to understand what the reliability of it, mathematically it is being proved in this white paper and the yellow paper of the Bitcoin on the blockchain. But the obvious evidence would be the blockchain has been running for the last 8+ years without being hacked. So that's one guarantee. So many people have tried to crash into it, break it, but that hasn't been possible. And as of now, there's $160 billion worth of Bitcoins available in this network. That means the individuals has put 160 million worth of money into the blockchain, and they believe that will be there for the future. The value of Bitcoin, yes, it has fluctuated, it has gone up and down, but that doesn't mean the blockchain has been ever hacked or is a broken system. It's a reliable and it has been reliable, and it will be reliable as well. So this kind of brings into the brief introduction of blockchain. Now I would like to give an introduction to Ethereum. This is basically a slight variation or improved aspect of blockchain. As I mentioned earlier, you can think of blockchain as a database. Like it records all this information in a database where you cannot easily change any of the records. So if blockchain is a database, Ethereum is the database plus the compute. So just to give a brief, explain it further, if you think of a database, you can, simple database, you could store data, you can retrieve data from that, you can do a lot of things with a database. But if you think you have a database, and on top of that, if you have a program running on top of it, the things that you could do is so much. That's what all these programmers are doing. They write programs to manipulate the data and manipulate the inputs, manipulate the outputs, and do all sorts of changes. So combining these two is the real value that Ethereum brings into the picture. So in Ethereum, they have two aspects. One is the state, which means all the data that you store would get stored in the blockchain, just like any other blockchain. But on top of that, there's a virtual machine, Ethereum virtual machine, which is doing the compute on the transactions that coming on. So combining these two has been much more powerful than a simple blockchain. So the programs that you write on top of the blockchain are usually called smart contracts, and so you can. It's a simple program at the end of the day. You can write that program, and that will be executed on every Ethereum node. I thought there would be a lot of developers here, and they would be a bit more interested exploring a bit about the blockchain or the Ethereum. So I thought of introducing few entry points or interesting aspects of Ethereum ecosystem. You could definitely, these would be entry points for you to study and learn more about Ethereum and blockchain. Solidity is a programming language widely used in smart contracts development. Remix is an online browser-based IDE, integrated development environment. Truffle is a unit testing platform. Infura is basically, you need a local, you need a full node running in your computer if you need to program for blockchain. But Infura take off that requirement, and it provides web-based nodes, so you could communicate with that using Infura. Web3.js is a simple library. This is a simple JavaScript library which enables you to communicate with the blockchain node. Few sets, again, you need Ether or Bitcoin for Ethereum transactions, Ethereum or any blockchain transaction. This is a place for testing purposes to obtain these tokens. MetaMask is an account management system, and Etherscan is a way of looking into what's happening in a blockchain. Blockchain has all the information in blockchain is public, so using Etherscan, you could look into what's happening behind the scenes, so what's happening in the blockchain database. Apparently, the application that you used to log in, everything was available on Etherscan. There was one link in the website somewhere. If any of you found that, you could go and see where your contract is, what transaction has happened, what coins has been received, and so on. So one of the most important thing, Consensus, this is one of the probably the largest consultancy company focused on blockchain. They apparently have built so much of tools around Ethereum. The founder of this company is again the founder of Ethereum, has been one of the Ethereum Foundation members. So they do a lot of developments around Ethereum and blockchain, and it will be important to keep an eye on them to understand what's happening in the ecosystem. Let me quickly introduce self-sovereign identity. Yeah, self-sovereign identity is a type of digital identity. We already have digital identities such as Facebook, Twitter, and GitHub. So there are a few problems with the digital identities. You cannot really trust who's behind that. There's no real proof of who's behind a particular digital identity. So this is a famous thing, like on the internet, nobody knows you are a dog. Like you could do whatever you want behind a computer, as long as you're using the internet. I mean, major claims, profile information has been get exploited, or people sell your information to other people, and actions can be correlated. I mean, what you do in Facebook, and if you do a purchase on eBay, and if you check some medical condition, I mean, all these things can be correlated by the people who has access to the information, and they could target you. These are not flexible. Like Facebook has your digital identity, but it is limited to set of attributes. You cannot bring in your professional qualifications or medical related information into Facebook profile. So the self-sovereign identity is trying to solve these problems. Just like the blockchain, since they are using the blockchain, there's no central authority really managing these identities. Owner will have the full control, who could see the information, who could not see, at which time the people could see your profile information, and so forth, so on and so forth. And the identity can be verified. So once after initial process, you could tie up your identity very clearly with the digital identity. Person can be directly relate with a digital identity, and that can be verified at any point. So this prevents correlation of information, where it has a primary identity, and for each purpose you could derive a secondary identity from your primary identity, and that secondary identity will be the one that used on that context. So if once you change the context, you could create a new identity for that, but except you, no one would know what this relation is. I mean, whether it is the same person or not. Finally, I mean, you could attach all of your qualifications, memberships, that kind of additional information with this identity, and those can be verified using a self-sovereign identity. Yeah, there are several self-sovereign identity providers or decentralized ID providers. Uport is one of them. I think you all registered through the Uport application would know a bit about Uport. Addition to that, there's this decentralized ID foundation, which completely concentrate on building this type of identity system. These identities are available, and people are really working on building systems around using these decentralized identities. So before I conclude my presentation, we have been the people who developed the registration process for you all. And we have developed another simple game which kind of depend on blockchain. And you will be able to participate in this game in an hour or so. So basically, once you log in to the system using, to the registration portal using your Uport ID, you will find a new tab which is called Game. Once you are in that game, simply it has a QR code and a way to activate a scanner. So as I said, this is an interactive game. In this audience, there will be about 30 to 40 people who matches your ID. I mean, there are about 30 people who matches each other's identities, which is stored in this QR code. So whoever finds a matching ID will be awarded with some tokens, and I think the person with most tokens will be kind of the winner of this game. So this is a bit of an interaction. So we would like to invite you all to try this out and see how this works, and try to gain a few more tokens from Google I/O extended event. So for us to build this system, there were a few guys really working hard to get these things done. So I just want to appreciate their effort. They have been working on this as a part-time thing while they are doing their daytime job. So they were so motivated and so helpful to make this a reality. And thank you guys. So we would like to, if any of you have any questions or like to get in touch with me, you can reach me on any of these things. And the Radical Age of the company we founded recently is hiring. And if any of you are interested in getting involved with blockchain-related developments, this would be an opportunity. Please reach me, reach our company, and we can have a chat about it. Finally, we have been working closely with Uport to make this event a success. So they were really excited to hear the interest that we have in Sri Lanka about Uport and decentralized IDs. So they are looking for a voluntary test panel, and they would be like to know. They like to know if any of you are interested in be a part of this voluntary test team, which you would be you will have first-hand experience of this upcoming technology. Please. Reach me, then I'll be able to connect you with them. So that concludes my presentation. Thank you very much for being part of this, and thank you very much.
A big thank you to Mr. Chim Himidumage. And we'd like to now invite on stage Mr. Saman Pereira, the Group Chief Information Officer of the SLT Group, who will present a token of appreciation to Mr. Chim Himidumage. So can we invite Mr. Saman Pereira once again on stage, this time to present a token of appreciation. And while Mr. Pereira comes on stage, the token also is brought, and we'd like to very warmly invite Mr. Chim Himidumage, blockchain enthusiast and founder of Radical Ledger and Fidenz. Come on, put your hands together louder.